Welcome to today's episode of the California GACCs Weather Terms video series. Our topic for today will be an overview of atmospheric rivers, which has been a buzzword regarding California weather in recent years. In this video, we will go over what atmospheric rivers are and why they are responsible for providing the majority of California's annual precipitation, as well as significant flooding. It is widely known that the climate in California is dry for most of the year, and most of the annual precipitation occurs during the winter. The reason for this is that the jet stream typically directs weather systems far north into British Columbia and the Pacific Northwest for most of the year. In the winter, the jet stream sags southward across the globe, allowing weather systems to move through California more periodically. This seasonal pattern change allows atmospheric rivers to take direct aim at California more frequently and thus brings significant precipitation. It is important to recognize that the degree of this jet stream shift is partly affected by El Niño and La Niña conditions. I won't get into specifics here, but generally during La Niña conditions, the jet stream remains farther north, thus typically keeps California drier, and the opposite for El Niño. This is why it is important to account for climate patterns when forecasting precipitation in California. You have probably heard a lot about atmospheric rivers, but you might not really know what they are. Atmospheric rivers are defined as long and narrow corridors of moisture along and ahead of cold fronts extending from low-pressure systems over the Pacific. Moisture from the tropics is transported into the U.S. West Coast like a fire hose, leading to substantial precipitation. This precipitation can last anywhere from hours to even days if the atmospheric river remains parked over one region. When atmospheric rivers are directed perpendicular to the coastal mountain ranges, extreme amounts of precipitation are likely due to orographic enhancement. Considering the sheer magnitude of moisture they transport, it is no surprise that atmospheric rivers typically produce over half of the annual precipitation for California. Much of this water is captured in reservoirs and leads to an increase in the state's water supply. With the amount of water they produce for the state, it is also no surprise that they frequently contribute to fire season slowing or ending events. However, atmospheric rivers also often contribute to major urban and river flooding, as well as debris flows across recent burn scars. Many of the most noteworthy flooding events in California, such as the Lake Oroville disaster in February 2017, can be attributed to atmospheric rivers which produced heavy rainfall in a short amount of time. You can see from the variety of potential impacts that atmospheric rivers could be a blessing or a curse depending on the circumstances. Due to the tropical nature of the moisture, atmospheric rivers tend to be warmer systems. This allows snow levels to remain very high, typically at least 7,000 feet. As a result, the highest mountain peaks will likely receive significant snowfall to add to the seasonal snowpack from these systems. Colder winter storms that do not have a tropical moisture feed are needed to bring snowfall to lower elevations. That's it for today's episode of California GACCs Weather Terms. We hope you now have a greater understanding of atmospheric rivers and why they are paramount for California's water supply, but also a significant flooding danger. Thanks for watching, and we'll see you in the next one.